Good evening, children. Good evening,
Good evening,
children.
ma'am.
Good evening. Yeah, so today, good evening.
Good evening.
Children. Good evening. Yeah, today is revision on volumes and surface areas. That's what I've prepared. Behind. Yeah, take down this question. Yeah, please make a note of this, children. Children, I'm sorry. I'll just get back. I'm sorry. Children, I'll just get back. I'll just put you with the first question because this I need to explain. I'll just put you with the first question. I'll just get back in 2 minutes. Please try this one, children. I'm just coming back in 2 minutes. Yes, children. Yeah, we'll continue with the 9th one. Yes. I hope you made a note of these two things.
Yes, ma'am.
All right. Now let's answer the question. All of you done writing this?
Ma'am, 1 minute, ma'am.
Okay. Yeah.
Yes, ma'am, completed.
Connect here. So when a right triangle is made to revolve about its hypotenuse, the solid generated is a the solid generated is a double cone. I'll share a video with you where you can see and understand clearly. See here. Now, this is the right triangle. This is the height. You can see the right triangle here. Let's call the right triangle ABC. Let's call the right triangle ABC. This is the right triangle with legs 15 centimeters and 20 centimeters. So this is 15, this is 20. This is the hypotenuse. See the right triangle. This is the right triangle. This is the right triangle. I've marked the right angle as A. AC is the BC is the hypotenuse. BC. Yeah. This is 15. AC is 20. So by Pythagoras theorem, BC is 25. So this right triangle is what you see BC as the base. Because you're turning it about BC. You're turning the triangle about the side BC, the hypotenuse. When you turn a right triangle, you have a right triangle with you, a right triangle ABC, right angle at A. The legs are 15 centimeters and 20 centimeters. With the help of the legs and by using Pythagoras theorem, you can find the length of the hypotenuse, which is not given. You find it using Pythagoras theorem, 25 centimeters. Now, when you turn this right triangle about its hypotenuse BC, when you turn this right triangle about its hypotenuse BC, the solid generated is a double cone. I told you I've shared the video. The solid generated is a double cone. So you're turning it about the hypotenuse, So when you turn it about the hypotenuse, the solid generated is a double cone. You will get a cone. The shape traced, the shape of the solid traced is a double cone. So you'll see a cone stuck on this side and this side. You cannot see, it's not magic. You cannot get a double cone. It will trace the shape of a double cone. When you turn the right triangle about the hypotenuse, as it moves, as it makes one complete rotation, the triangle will trace the shape of a double cone. The triangle cannot become a double cone. So you will see that you can see that a cone is traced on this side and on this side. The base is common. The circular base of both the cones is common. The circular base of both the cones is common. You can see one. Okay, let me call this A dash. So you can see this A dash, a small cone on the left side, and A dash, a slightly bigger cone on the right side. ABC is the right triangle, right angle at A. BC is the hypotenuse. AB and AC, the legs, measure 15 centimeters and 20 centimeters. When we turn this right triangle about the hypotenuse BC, The solid traced is a double cone. A double cone meaning you can see here in this figure, you can see a cone to the left and the right. You can see a cone on the left side A, B, A dash, and on the right side A, C, A dash. The radius of both the cones is the same because their circular bases are stuck. Their circular bases are stuck, so they have the same radius. They have the same radius. Okay, they have the same radius. This one. Radius is the same for both the cones because their circular bases are stuck. Let me mark this point. Let me mark this point D, this point D. So BD is the height of the small cone and CD is the height of the big cone. BD is the height. See, when we're talking about cone, we are interested in the radius, height, and slant height. When we talk about a cone, we are interested in the radius, perpendicular height, and slant height. Now the slant height is, for the small cone, the slant height is 15 centimeters, and for the big cone, the slant height is 20 centimeters. It's evident from the figure there. For the small cone, the slant height is 15 centimeters, and the slant height of the big cone on the right side is 20 centimeters. Now coming to the radius and height, the radius is the same for both the cones. Okay, we can find its value, but actually you don't need its value. Oh, sorry. The height of the small cone BD, which is H1. I'm distracted. Sorry. That's why I had to take a break in the middle. Also, I'm sorry. So BD is the height of the small cone. CD is the height of the big cone. H1 is the height of the small cone. H2 is the height of the big cone. You don't have to find the heights. You don't have to find H1 and H2. You can find H1 and H2, but you don't have to actually find them to answer this question. Find the volume and the surface area of the double cone so formed. To answer that question, you don't have to find H1 and H2. You need to find the radius. You need to find the radius. All of this can be found. You can find the radius. You can find H1. You can find H2. Everything can be found, but you don't need the values of H1 and H2 is what I'm trying to say. So again, right triangle. We'll just see the same thing again. I don't want to erase that because I don't know if I can get it like that again. So I'll draw. So this is the right triangle. This is the right triangle ABC. This right triangle ABC. See, legs are 15 and 20. No, see, we've marked the legs 15 and 20. Okay, so this is the right triangle ABC. So BC is the hypotenuse. Please watch carefully. See, BC is the hypotenuse. You've just turned the triangle. You want to rotate it. You want to turn it about the side BC. You want to turn the right triangle about the hypotenuse BC. So you're having it like this in your hand and you turn it. You turn it about BC. Okay. So the solid generated will be a double cone. Double cone. Okay. All right. So I've called this D. I've called this one D. This is the radius. This is the radius. This is BD H1. BD is the height of the cone on the left, and CD is the height of the cone on the right. Now let's understand how to find the radius and the height of the two cones. So slant height we understood. Slant height of the cone on the left side is 15 centimeters. Slant height of the cone on the right side is 20 centimeters. So slant height we have. So radius H1 and H2. Radius is the same for both the cones. We'll find that. The heights are different. BD is H1, CD is H2. The heights are different. We can also find them. Let's see how to find them. Okay. Now, let us prove. See, we have a figure like this. We have a figure like this. If you see only the top part, we have a figure like this. See, this is A, this is B, this is D, this is C, this is R, this is H1, this is H2, this is 15, this is 20. And we know that this is a right angle. This is the right angle. Please draw these two figures, children. Because the space is limited to the screen, I need to erase. Please take down these two figures in your book. Done, children?
Yes, ma'am.
Yeah. So now with respect to this figure, it's, see, this top portion is what you see here. A, B, D, C, H1, H2, R, 15, 20. Now here, how many right triangles do we have in this figure? How many right triangles do we have in this figure?
3, ma'am.
3 right triangles. What's the length of BC? What's
20.
the length of BC?
H1
Sorry?
plus H2.
No, the numerical value of BC.
25 centimeter.
How? It's not given.
We can find by Pythagoras theorem.
Yeah, we can find it using Pythagoras theorem. We can find it using Pythagoras theorem. All right. So by Pythagoras theorem, you can find that BC is 25 centimeters. Now take any one of the small triangles. You need 2 right triangles here. There are 3 right triangles in all. I'll tell you another way of doing this also, children. This is using similarity. I can also tell you using the formula half base into area of a triangle. We'll see that also. This is easy. This easy meaning let's use some new concept. Area of triangle, we already know. We'll see how to use similarity here. There are 3 right triangles. 1, 2, and the whole triangle ABC. There are 3 right triangles. Choose any 2 and prove that they are similar. Choose any 2 and prove that they are similar. I'm going to choose this one and the whole triangle. I'm going to choose this little triangle, this small triangle ABD. I'm going to take the small triangle ABD and the whole triangle ABC. Okay. I'm going to take the small triangle ABD and the whole triangle ABC and show that they are similar. How? In ABD, we have this angle. We have this angle. In ABC also we have the same angle. So this angle 1 is common to both the triangles. So angle 1 is equal to angle 1, common angle. Angle 1 is, you see, angle 1 is a part of triangle ABD. Angle 1 is a part of triangle ABD. Angle 1 is also an angle of the triangle ABC. So common angle. Then angle 2 is equal to angle 3. In the small triangle, angle 2 is 90 degrees. And in the big triangle, angle 3 is 90 degrees. Because it's a right triangle, no? ABC is a right triangle. Angle 3 is 90 degrees in the big triangle. And the small triangle, angle 2 is 90 degrees because it's a cone, radius and height perpendicular to each other. Here. So now by doubling similarity criterion, the two triangles are similar to each other. So how do we write the proportion? How do we write the proportion? Let's write from the common angle. If I call this small triangle, the common angle B, the right angle D, and the third vertex A. So going in this rhythm, common angle B, right angle A, the third vertex C. Let me write it again. Let me write it again. The same thing again. See here, this is the small triangle. I told you small triangle and whole triangle. In the small triangle, B is the common angle. D is the vertex containing the hypotenuse. Oh, sorry. My God. D is the vertex containing the right angle. I have this much of problem, you know. I get somebody comes in between my classroom to say something, ask something. This is what happened, and I'm sorry to waste your time. B is the common angle. B is the common angle. Angle 2 is 90 degrees. That is the vertex D contains a right angle. And then the third vertex A. The third vertex A. BDA. So we'll call the small triangle like this. The big triangle, we'll go with the same rhythm. Common angle B, right angle A, third vertex C. Similar. Now write the proportion. BD by BA is equal to DA by AC is equal to BA by BC. Reason, in similar triangles, corresponding sides are proportional. Please write down, children. Please write down. We have proved that two triangles are similar. And in similar triangles, corresponding sides are proportional. Yeah. So now substitute the values. See, why are we doing all this? Because we need to find the radius. I told you H1 and H2, we'll find now, but you don't have to find, is what I said. We'll find H1 and H2. We need to find the radius and the height of the two cones. That's why similarity. Now BD, what is BD? Look at the figure H1 by BA. What's BA 15 is equal to DA. How much is DA? DA is the radius R. Okay, by AC 20 is equal to BA 15 by BC 25. So children, can we equate these two and find R?
Yes, ma'am.
Yeah. So R by 20, please work. R by 20 is equal to 15 by 25 and find the value of R. Similarly, you can equate H1 by 15 is equal to, if you find R, you can equate anything. Like that, equate and find H1. H1 by 15 is equal to 15 by 25 you can do. Please, and once you find H1, H2 will be 25 minus H1. H2 will be 25 minus H1. That's it, we got everything.
Ma'am, radius is 12, ma'am.
12, huh? Okay. So R is equal to R
Ma'am,
by
radius
20
is
is
12
equal.
centimeters.
Okay. So R is equal to 15 into 20 by 25. So it's 300 by 25. Yeah, so R is equal to 12 centimeters. And what about H1, children? H1 and H2?
9 centimeters.
9. H1 is 9. Okay, and H2 will be 25 minus 9, which is 16 centimeters. All right. All of you, please find that. Please equate after finding R. All of you find H1, and then H2 is 25 because H1 plus H2 is 25. H1 plus H2 is 25. So after finding H1, you can find H2. So now we have all the values, radius and height. Complete and tell me, you're done. All right. So now volume of the double cone. Volume of the double cone. I'll just write DC. Volume of the double cone is equal to volume of the small cone plus the volume of the cone. So 3 pi r square H1 plus 1 by 3 pi r square H2. It's going to be r in both the cases because the radius is the same for both the cones. The volume of the double cone. DC is double cone. Volume is volume of the small cone plus the volume of the 1 by 3 pi r square H1 plus 1 by 3 pi r square H2. R is the same. You don't have to say R1, R2 because the value of R is same for both the cones. H1, H2. So what's common, children? What is common? What is
1 by 3
common?
pi r square, ma'am.
1 by 3 pi r square. So in the bracket?
H1 plus H2.
H1 plus H2.
Okay. So 1 by 3 into pi is 3.14. It's given into r square. So 12 square. Am I right? 12 square.
Yes, ma'am.
Into, now children, H1, H2, if you found the values, you substitute them. But what is H1 plus H2? 25, right?
25 centimeters.
Yeah, you can write 20. That's what I said. You don't have to find H1 and H2. That's what I meant by saying you don't have to find H1 and H2 because anyways, we know we don't need H1 and H2 individually. We need H1 plus H2 and that we already know is 25. It's fine if you found H1 and H2, you will substitute 9 plus 16. So you will get 25. 9 plus 16, 25 you will get. Now calculate this, children. This will be the volume of the double cone.
From 3768.
Okay, I'll just go with your answer. I have not calculated. 3768, is it?
Yes.
Perfectly, yeah? Exactly 3768, Shakti?
Yes, ma'am.
Okay, centimeter square. Very good. Let me also check. I have the calculator beside me. 3.14 into 144 into 25 divided by 3. Perfect. 3768 centimeter cube. Volume centimeter cube. This is about volume, children. Now let's find the surface area. We found the volume. Next, we have to find the surface area of the double cone so formed. So when it is surface area, is it the total surface area or the curved surface area? Is the total surface, are the circles of the two cones visible?
No, ma'am.
Are the circular portions of the two cones visible? No. If you
No.
have to paint this double cone, where will you paint? You will paint the CSA of the small cone and the CSA of the large cone. The two cones are stuck to each other. Their circles are not visible. Their circular portions are not visible. So you will be painting only the curved surface area of the small cone and the curved surface area of the big cone. So the surface area, let us say surface area of the double cone. Let's say surface area of the double cone is equal to surface area is pi r l. Okay, so it will be pi r L1 plus pi r L2. Surface area of the double cone, the total area will be the CSA of the small cone plus the CSA of the big cone. Pi RL plus pi RL. But we should say pi R L1 plus pi R L2. R is the same for both the cones. What's common?
Pi r, ma'am.
Pi r, ma'am.
In the bracket,
L1 plus L2.
L1 plus L2. So 3.14 into 12 into L1, which is 15, plus L2, which is 20. So you see here in our calculation, we just needed the value of R. We did not. See, that's all you can, these are the questions that can be asked about a double cone. Volume, surface area, finished. So for volume also, so we did H1 and H2. We just needed the value of R. And for the curved surface area also. Slant height is already known. We only need the value of R. So remember that, just find R. And you can answer volume and surface area. Yes. So on the calculator, I see 1318.8 centimeters square. Wasn't that easy, children? No. Difficult?
No, ma'am.
It's easy only.
Very good. Let's see the alternate approach now. That's very easy. The alternate approach is based on the formula half base into height. I just wanted you to know that you can do this using similar triangles. You can do this using Pythagoras theorem. Okay, so the next method. Okay, so what is the area of the triangle? So this is the next method. It's not the continuation, children. We are done with the first method using similar triangles. Using similar triangles, we have found the volume and surface area. It's over. Now this is an alternate method. It's not the continuation. It's an alternate method. So start new. Area of the triangle. Area of the triangle ABC. What is the area of the triangle ABC? Half base into height. AB into BC. Because half product of lengths, right? So half into 15 into 20. So that is 150 centimeters square. The area of the triangle ABC is 150 centimeters square. Write down all of you. The area of the triangle ABC is 150 centimeters square. Half product of lengths. So now we found that the area of the triangle ABC is equal to 150. Now take a different base, half into, if I take BC as the base and AD as the altitude, then also the area will be 150. I'm taking a different base. I'm taking the hypotenuse as the base. And the corresponding height is AD is equal to 150. Same triangle. Same triangle. Area of ABC, half base into height, we found 150. Now I'm taking the base as BC and its corresponding altitude AD. That also the area should be 150. So half into BC is 25. The hypotenuse you should find using Pythagoras theorem is equal to 150. So AD is equal to 150 into 2 by 25. So AD is equal to 12 centimeters. So you see that the radius is 12 centimeters. That's all. First find the area of the triangle. Okay, write down children. Let me not keep talking. So find the area of the whole triangle. That's all. Find the area of the whole triangle. ABC half base into height. 150. Now use the hypotenuse as the base and AD as the altitude. So like that you can find AD. That is the radius is 12 centimeters. And I told you radius is sufficient. You don't have to find. Then you can proceed to find. Once you find the radius, you can proceed to find volume and surface area. Is it clear, children?
Yes,
The rest
ma'am.
of the answers, yeah, the rest of the answer is like what we did earlier. Volume and surface area, same steps. We found the radius. AD is the radius, 12 centimeters we found. You don't have to find H1 and H2. Okay, over to the next question. So a solid wooden toy is in the form of a hemisphere surmounted by a cone. Is in the form of a hemisphere surmounted by a cone. Hemisphere surmounted by a cone. Okay. Of the same radius. Okay. Okay, so this is how the wooden toy is in the form of a hemisphere surmounted by a cone with the same radius. The radius of the hemisphere is 3.5. That means the height of the hemisphere is also 3.5. The height of the hemisphere is 3.5. The radius of the hemisphere is 3.5. The radius of the cone is also 3.5. And the total wood used in making the toy is given there. Find the height of the toy. You need to find the height of the toy. Also find the cost of painting the hemispherical part at the rate of rupees 10 per centimeter square. So, volume of toy is equal to 166 5 by 6 centimeter cubed. So volume of toy means volume of hemisphere plus volume of cone is equal to 1001 by 6 centimeter cubed. Volume of hemisphere is 2 by 3 pi r cube plus cone is 1 by 3 pi. You can use the same r because radius is the same. Pi r square h is equal to 1001 by 6. Now what's common? 1 by 3 is common, pi is common, r square is common. Because r is the same for both the solids. 1 by 3 pi r square is common. Open bracket 2. Because 2 into 1 by 3 is 2 by 3. R plus h is equal to 1001 by 6. So 1 by 3 into 22 by 7, is it given 3.14? No. So into 22 by 7 into r square. Radius is 3.5. Let's take 7 by 2, children. Decimal, I don't want to take decimal. I'll take 3.5 as 7 by 2. I'll take the 7 by 2. Okay, into 7 by 2. I'm taking 3.5 as 7 by 2. So you can cancel also. See here, you can also cancel. Then twice 2r. 2r means 7. 2 into 3.5 is 7. Correct? 2r. 2 into 3.57 plus h. H is what? The height of which one? The height of the cone. The height of the cone we don't know. That's what we have to find. Height of the cone. This h is the height of the cone. 1 by 3 pi r square h. Height of the cone. We don't know the height of the cone. It's not given. Is equal to 1001 by 6. Work this and find the value of h. Work this and find the value of h.
6 centimeter.
So what's the height of the toy?
6 centimeter.
No, height of the toy.
9.5.
9.5 centimeters. Which is 6 centimeters. So the height of the toy, we need to find the height of the toy. Height of the toy is equal to height, the toy, full thing. This full thing is the toy. So it's the height of the cone plus the height of the hemisphere. The height of the toy is the height of the cone, 6 plus the height of the hemisphere, 3.5. So 9.5 centimeters. The second part is simple. Cost of painting the hemispherical part. What's the formula?
2 pi r square.
2 pi r square. So simply find 2 pi r square and then into 10 will give you the answer.
770 rupees.
Let me check. Yeah, 770. Would be 770. Correct. Done, children? All right. Next one. Try a water-based question, children. 1 minute. Yeah, we'll do this. We'll do this one. Take down the question. Okay. So a cylindrical tank is being filled by means of a cylindrical pipe. Okay, I'll give you some time to read the question. Write and read the question. Okay, so there is a cylindrical tank. There is a cylindrical tank and there is a pipe, a cylindrical pipe. The tank is being filled by means of the pipe. The tank, water is filled in the tank by means of the pipe, the cylindrical pipe. So how long is the water let to flow into the tank, children? How long is the water allowed to flow into the tank? Half an hour. Is the tank empty or full initially?
Initially empty.
It's empty. The tank is empty initially. Then water is allowed to flow into the tank. So what will happen when water flows into the tank? The level of the water will keep increasing. First it was empty. First the height of the water was 0. There was no water in the tank. Initially there was no water in the tank, empty tank. So the height of the water in the tank 0. Now water is allowed to flow into the tank for half an hour. So the water in the tank will have some height. You need to find the height of the water in the tank. You need to find the height of the water in the tank. Okay. So the pipe is cylindrical, the tank is cylindrical. Let's write out the values given. For the pipe we have diameter is 2. So the radius is 1 centimeter. And water is flowing at the rate of 0.4 meters per second. Now what have I done? Or maybe I'll not convert it here for you. I'll do it in the answer.
I'm converting meter into centimeter.
Yeah. Oh, sorry, not 44. So we're trying to have everything in the same unit, meter, centimeter. And for the cylindrical tank, radius 40 centimeters, height we have to find. Height we don't know, we have to find. So this is the equation. Volume of water that flows out of the pipe, flows out of the on one side you should have pipe, on the other side you should have cylinder, and you should write a relation connecting both. So volume of water that flows out of the pipe in 30 minutes is equal to the volume of water collected in the tank in 30 minutes. In the tank in 30 minutes. That is, for the pipe, water is flowing out. And for the cylinder, the cylindrical tank, water is being collected into it. The volume of the water that, so on one side, you can write anything first. It's not that you can have anything on either side. You can have pipe on, you should have pipe on one side and the cylindrical tank on the other side. That's all it is. So for the pipe, what do you say? The volume of water that flows out of the pipe in 30 minutes. For the cylindrical tank, what do you say is equal to the volume of the water collected in the tank in 30 minutes. We know that these two volumes are the same because whatever water flows out is collected in the tank. So the volume of the water that flows out is equal to the volume of the water that's collected in the tank. So here, the volume of the water that flows out is pi r square h because it's flowing out through a circular mouth. Pi r square h. So pi r square, but that's h is for 1 second. H given there is per second. So for 30 minutes, it will be, see, the height is 4 centimeters per second. In 1 second, the height of the water that's discharged is 4 centimeters. For 30 minutes, For 30 minutes, it will be into, when you multiply by 60, you will get for 1 minute. And when you again multiply by 30, you will get for 30 minutes. Write it again. See here. I'll do it again. Pi r square h. H is 4 centimeters per second. Height of water 4 centimeters. That height of water comes out in 1 second. But in 30 minutes, what is the height of the water discharged? In 30 minutes. So for 1 second, it is 4 centimeters. If you multiply that by 60 seconds, you will get for 1 minute. Per second, no. When you multiply that with 60, you will get for 1 minute. 1 second into 60 is for 60 seconds. That is 1 minute. This is 1 minute now. For 1 minute, the height for 1 minute. Now into 30 will be for 30 minutes. Four centimeters for 1 second. So how much for 1 minute? Into 60. 1 second. In 1 second, 4 centimeters. So in 60 seconds, how much will come out? Into 60. So when you do into 60, that is for 1 minute. And that if you multiply by 30, you will get for 30 minutes. Is equal to the volume of the water collected in the tank in 30 minutes. That is pi r square h. Pi r square h. So pi gets cancelled on both the sides. R, what's R1? 1 square into height. H 4 centimeters. 60 into 30. 4 centimeters. This is for 1 second. Into 60 for 60 seconds. That is 1 minute. Into 30 is for 30 minutes. Is equal to 40 into 40 into h. H is what we have to find. Work this and find the value of h.
Ma'am?
Yes.
Ma'am, I have a doubt in the speed for pipe column.
Yeah, please ask me.
0.4 meter to centimeter, it will be 40
No, it will be
centimeters.
40. No?
Oh, I'm sorry.
Into 100.
Meter to centimeter into 100, right?
Yes,
Oh, yeah. I'm sorry. Yes. Into 100. Yeah, you are right, Arnav. Thank you. Meter to centimeter is into 100. Yeah, so it will be 40. Thank you. So here it will be into 40, right? Yeah. Yes, Arnav. Thank you. 1 meter is 100 centimeters. So converting meter to centimeter into 100.
Is it 45 centimeters rise?
45, is it?
Yes, ma'am.
Yeah, let me check.
Yes, ma'am, 45. Ma'am.
45. Others? All of you?
Yes, ma'am.
All right. So just write the equation in words. You'll always have one thing from where the water is being filled and the other thing where the water is collected. Every time this will be the equation. The volume of the water that flows out of one thing is equal to the volume of the water that's collected in the other thing. So for the pipe, that's the height of the water that comes out in 1 second. You should find the height of the water that comes out in 30 minutes. In 1 second, 40 centimeters comes out. When you multiply 1 second with 60 seconds, that will be for 1 minute into 60. That will be for 1 minute. And that 1 minute again into 30 will be for 30 minutes. So that is the volume of the water that comes out of the pipe in 30 minutes. And that's equal to the volume of the water that's collected in the tank in 30 minutes. So radius we know. And H is what we have to find. That's all. All it should be. Try this one. There in the earlier question, time was given. You have to find the increase in height. Here the height of the water, not the increase in height, that's what the level of the water. In the earlier one, time was given 30 minutes. You have to find the level of the water. Here the level of the water is given and you should find the time. Here the level of the water is given 7 centimeters. You should find the time. How long will it take for the level of the water to rise in the tank by 7 centimeters? Yes, please work, write the equation like we wrote in the earlier one. Volume of the water that flows out of the pipe in 1 hour. Please work and share your answer on WhatsApp. Please be careful, convert everything to the same unit. Maybe everything to centimeter or everything to meter. Centimeter is the smallest of the units here. We have 3 units, kilometer, centimeter and meter. You can see the values given in kilometer, centimeter and meter. Convert everything to centimeter.
Miss, Miss answer is 1 hour. ma'am.
What's the answer?
1 hour, ma'am.
1 hour. Huh?
Yes, ma'am.
Yeah, you're right. 1 hour. So when you add 3 zeros, it's converted to meters. And meter to centimeter, 2 more zeros. So many centimeters per hour. 6 kilometers per hour. I converted it to meters first. I added 3 zeros. And then from there to centimeter, 2 more zeros. This is given about the pipe. And about the tank, which is cuboidal. For the tank, we know the length of the tank. The length of the tank is 60 meters. That is 60 followed by 20 centimeter. The breadth of the tank is 22 meters. 22 followed by 20 centimeter. And the height of the tank we don't know. We are only interested in the height of the water. The height of the water in the tank is 7 centimeters. The height of the tank may be anything. We are only equating the water in both the cases. So the height of the water is 7 centimeters. So let the time taken be something like T hours. We'll say hours because here we have it in hour. So we'll say it takes T hours. Let the time taken be T hours. So pipe, so volume of water, same thing, volume of water that flows out of the pipe, volume of water that flows out of the pipe in T hours, is equal to volume of water collected in the tank, So the volume of water that flows out of the pipe, it's a cylindrical pipe, so pi r square h. This much comes out per hour because the height is per hour, right? 6 kilometers per hour. Like this, it is let open for T hour, so into T. Pi r square h. The height of the water is given per hour. 6 followed by 50 centimeter, that height of water is discharged in 1 hour. So like that, you don't know, you're keeping it open for 2 hours, 3 hours, how many hours, we don't know. So if you're keeping it open for T hours into T, in 1 hour, this volume of water comes out. In T hours into T. See, like 1 hour pi r square h, 2 hours into 2, 3 hours into 3. So in T hours will be into T is equal to LBH. Here the formula to find the volume is LBH. So since we cannot cancel pi on both the sides because we don't have pi on the other side, we'll use the value of pi 22 by 7 into r square. You can see there in the substitute into 6 followed by everything in centimeter, children. See, pi is 22 by 7. R is 7 centimeters. H, height, this one, 6 followed by 5 zeros. That is for, this height is for 1 hour. For T hours into T is equal to LBH. This in centimeter into this also in centimeter, and this is in centimeter. That's all. Now work this and find the value T. So mostly, not mostly, sorry, somebody told me it's, so the numerator and denominator will be the same, 1 hour. 1 hour is the correct answer. Please check if you're getting that in this working.
Yes, ma'am, I got 1 hour only.
Yeah, right. No, from what I have written on the screen.
Yes, ma'am, I have done by this method only, ma'am.
Okay, fine. All right, children, please complete this. Very important is to have all the values in the same unit. Is it over, children?
Yes, ma'am.
Yes,
Okay.
ma'am.
All right. Class, use the emoji. Raise your hand. Very good. Dinesh, Riya, Priya, Arnav, Shakti, Mutubel, Lakshita, Niveta, Shruti, Sudarshan, Priyadarshini, Aksharam, and Shivani. Hope Shivani is there. You can probably take a screenshot of these questions, children. We'll try one more in today's class. Please take a picture of this question. Yeah, we'll do this one. We'll work this and wind up the session for today. So volume of one toy. Volume of one toy into 12 will be the volume of all the 12 toys. And that's equal to the volume of the cylinder. Sorry. So given that the height of the conical part is thrice the radius. The height of the conical part, the height of the cone is 3 times the radius. The height of the cone is h. H is the height of the cone because 1 by 3 pi r square h is the height of the cone. It's given it's 3 times the radius. So 3r. So the radius of the hemisphere and the radius of the cone is 3 centimeters. Find the total height of the toy.
From 12 centimeters.
Yeah, the height of the toy is 12 centimeters. So you should not be in a hurry to substitute the values. Values we can substitute slowly. First you simplify, you take out common, you cancel, do all that and then substitute the value. See here, till here I did not substitute anything. Till here I did not substitute anything. There's no hurry, values are there only, we can substitute anytime. We'll first simplify the equation by cancelling how much ever possible, taking out common and all that. So please look at your screen. That this is the volume of the hemisphere. This is the volume of the cone. Volume of hemisphere plus the volume of the cone is the volume of one toy. This is the volume of one toy. Volume of cone plus volume of hemisphere is the volume of one toy into 12 is the volume of the 12 toys. And volume of all the 12 toys is equal to the volume of the cylinder, which is pi r square h. Now I've taken out common. And the bracket we have this is equal to pi r squared. So I did not substitute the values. I cancelled pi on both sides and 3 1s are 3 4s are. And then this h, very important, height is given to be 3 times the radius. So instead of, see in one equation, see we know the values of r and h. We should have only one unknown in one equation. H is also given to us in terms of r. H is 3r. H is 3r. So then after substituting the values of r and h, you see that this equation has only one unknown r. This equation has only one unknown r. Be careful, 4r square into 5r is 20r cubed. R square into r is r cubed. The value of r is 3. That is, the radius is 3. And the height of the toy is the height of the cone plus the height of the hemisphere. Height of the cone plus the height of the hemisphere. Height of the cone is 3r. It's given. The height of the conical part is thrice the radius. This is 3r and this is r. So 4r is the height of the cone, which is 12 centimeters. Tell you again. Height of toy is equal to height of the cone plus the height of the hemisphere. Is the height of the cone plus the height of the hemisphere. Height of the cone is 3 times radius plus height of the hemisphere is radius. So it is 4r or 4 into 3. R is 3. 4 into 3, 12 centimeters. Yes or no, children?
Yes, ma'am.
All right. You can try to get a question bank available there, or you can, get it online. Get a question bank so that you have some papers to solve when you're free at home. Oswald or Arihant. Only sample papers. So that you can, solve question papers when you're free. All right, children. I hope all of you finished writing.
Yes, ma'am.
Okay.
Yes, ma'am.
All right, children. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Good night.